Okay, I think it's recording now. Uh, can you retaking summer school? Yes, you can retaking summer school. 102 is usually offered in summer as well. Don't give up yet. You still have 3 more quizzes. You can drop the lowest one. Next quiz. This is next week. You have a whole week to prepare for it. Honestly, I don't know what else I can do to help you anymore. Um, I saw a lot of people were devastated after they saw their quiz mark, but I just want to say a lot of people found the first quiz the hardest. Well, I don't find the first quiz the hardest, but yes, it's released. Problem set D is released, so you can start practicing already. I don't think it's the hardest, but a lot of students think it's the hardest. So you might agree with them. So the thing is like it's just one quiz and you can drop it. It's not the end of the world. You can just try harder and get better, I guess. Let's face the reality. It's well, I agree. I think it's the easiest, but a lot of people they tend to do better on the other quizzes because like during the first month of 102 usually people don't get it, but after they start to practice more and more it gets easier for them because they're kind of used to it. They're kind of used to thinking in this way. They're used to doing proofs, so they do perform much better on the second and third quiz, not the last quiz though. Usually people don't do well on the last quiz. Problem set C is due this Saturday, yes. So problem set C, you need to hand it in. For problem set D, it's for practice only. You don't need to hand it in. The next quiz, will be based on problem set D. Does that make sense? I will try to mark your problem set B so that I can give you some feedback before problem set C is due. But um, I can't guarantee anything because I'm teaching another course, and the other course they have problem sets every single week, and I'm grading everyone's problem sets, so it's a lot of work. So if we are able to complete the problem set D, we will be able to complete the quiz just fine. I think so, but I can't guarantee because I said the same thing for the first problem set, and apparently you guys don't agree with me. One thing that's really important is that people usually perform much worse when they are under pressure. So when you do problems, you have to make sure you time yourself and finish it within a short amount of time. So if you're giving yourself a lot of time to do one question, but during the quiz or the test you don't have that much time, you'll get really nervous and freak out, and you might blank out as well. So I don't suggest that. When you try to do a problem set D, you treat it like a quiz. You only give you yourself 10 minutes for each question, no more than that, okay? You should not use more than 10 minutes. I would say usually you should be able to finish it within 5 to 8 minutes. Don't even use 10 minutes. Yeah, so try to finish each question within a really short amount of time. Give yourself the pressure when you do practice so that you can perform better during quizzes. Actually, let's do this. So I will post I will send you an email or I'll post an announcement for feedbacks. So the feedbacks, um, I I will ask you about feedbacks for tutorials, and also what do you think I can do to help you do well on the quizzes. Okay, so I'll ask you about that. It's gonna be anonymous, so you don't have to worry about anything because I don't know who wrote that. Anyway, I usually do it every semester. Didn't do it during summer because we're doing the same thing. I mean, now we're doing the same thing as well, but I really want to be helpful. So I will send you an announcement or an email. Check that, and I want people to give me feedbacks so that you guys can do better. Okay? So, any question before we start the tutorial activities? Question? Okay, no one said anything, so I suppose no question. Alright, let's look at the tutorials. So in this week, we'll talk about functions, which includes domain, codomain, and image of a function. You should be able to distinguish the difference between codomain and image of a function. Also, you should be able to prove a given set is an image of a function using double inclusion, and identify a given set as a field under the two specific operations. Evaluate an expression of elements in the field and find its value. Prove equality or subset inclusion of functions of sets involving set operations. Alright, let's just cut straight to the activity. So, activity 1, part 1. You have a function, f, that maps from natural Cartesian product integers to real numbers, where your fmn equals to 2m plus n. Now, the first question is, what is the domain of the function? Domain natural times integers. Yes, natural Cartesian product integers. Okay, what is the codomain of the function? Real numbers, exactly. Okay, now they want you to compute the following three things. So first of all, what is f1 minus 1? f1 minus 1? 1. Okay, so 2 times 1 plus negative 1 will give you 1. What about f of 1 negative 2? What is that? 0, okay. F of 1 negative 3. Negative 1, exactly. Alright, so number 4, based on number 3, it should give you some ideas of the image. So anyone know what is the image of the function? So for image of a function, we denote it by f of the domain, okay? So this means the image of f. This is a notation. So what is this? The image of the function is z. Okay, exactly. It's all the integers. Okay, based on 3, you can see that we can map to every single integers. Okay, so if you go on, so let's say 1, 0 will give you 2, and 1 negative 4 will give you negative 2, and such. So you can go and continue, and you see the image is all the integers. So this one's easy. Anyone need me to clarify anything? Is this clear? Any question? Is the image just range? Yes, image and range, they are interchangeable. Okay, any other question? Cool, let's move on then. So part 2 of activity 1, we have another function g that mapped from R to R, where your gx is negative 2 minus the absolute value of 3x. Now, my first question is, what is the domain of the function? R. Okay, so this is your domain. What about codomain? What is the codomain of the function? R again, exactly. Okay, so this is your codomain. Now I'll give you 5 minutes to think about what is a range. No, not oh, image. Think about what is the image of the function and then try to prove it. So one thing I want to say is in 102, we don't care how you found your image. We just need you to find it and then prove it is the image. So whichever way you use to find it, we don't care. Okay, just make a claim and then start to prove it. Again, I'll give you 5 minutes to think about it, and we'll take it up at 5:26. While you guys do that, let me make a Google form and send it to you so that everyone can give me feedbacks. Where's my pen? How did you guys find the motivation to study at home? I feel so bad for you guys since everything is online. Cause I graduated in June, so I had the experience of doing things online. And when, like last year, when they changed everything to online, I was like, I lost all my motivations. I couldn't do anything. I was just like staying in my bed every single day. No motivation to study, push myself to do, paying for online courses. Yeah, I feel like I would do better if like I think most people would do better if it's in person. If you get 50% discount on your tuition fee. I mean, if you're paying less, I'm not sure if you can do better if you're paying less. Honestly. Yeah, I graduated already. Right now I just have to work. I don't even need to study, but I have no motivation to work at home either. Like I wish I can go somewhere else to work, but like right now I heard they found a case. Oh yeah, I heard they confirmed a case at UTM, so guys stay at home. Don't go to the campus, okay? Two cases? Two cases for what? Oh, okay. Oh, I see, I see. I think they sent out an email said it's one case. It's recently, uh, let me check. So, yeah, so they said Peel Public Health has confirmed a case of COVID-19 on the University of Toronto, Mississauga on September 28th. And anyone who visited the following areas on the dates below should monitor themselves for symptoms of COVID-19. If you visited McGrath Valley Laundry Room on September 22nd, OPH Oscar Peterson's Hall Food Services from September 23rd to 27th, or Davis Building Meeting Space and Food Servery, afternoon of September 23rd, or OPH Lobby Vending Machine first floor, September 25th. So if you visited those places on those dates, you should monitor your health, okay? Yeah, anyway, okay, it's 26 already. Let's talk about math. But if you visited those areas, you should stay at home and monitor your health, okay? Anyway, anyone found the image of the function? Anyone found the image of the function? No, it's not infinity to zero. Think again. It's not R. No, Andrew, you are close, but no. Everyone else, you guys are away. Oh, okay. One of you found the correct answer. Yes, it is. One of you found it is less than or equal to -2. Okay, claim that the image of the function is from -infinity to -2. No, not -2 to infinity. It's from -infinity to -2. Why -2? Okay, so look at this function. You'll see that this is definitely positive, which means you minus a positive number is gonna get smaller and smaller. Okay? Since it gets smaller and smaller, you know one side is gonna be -infinity, and you minus a number so the minus a number. So this whole thing is gonna be the biggest when this equals to 0. So that's gonna be -2. Okay, so let's prove it. Proof. So we first want to show the image, which is, no, I used F again. It's G. G of R is a subset of negative infinity to negative 2. Then you want to show the interval negative infinity to negative 2 is a subset of G of R. Okay, so you want to show those two things. Let me move it a bit. You want to show this. So the first one, let's pick an arbitrary element y be an element of G of R. This means y is an element of the image of G, which means that there exists x in your domain such that G of x equals to y. Okay, since we know that, we know y equals to negative 2 minus absolute value of 3x. And now you just need to show this whole thing is in between this. So you need to show your y is less than or equal to negative 2. So that's your goal here. So this is going to give us absolute value of 3x equals to negative 2 minus y. Since we know the absolute value of x, no, the absolute value of anything is going to be greater than or equal to 0. Okay, since it's absolute value, we know this is greater than or equal to 0, which means this is greater than or equal to 0 as well. So you need to move your y to the other side. That's going to give you y is less than or equal to negative 2. Which means y is an element of negative infinity to negative 2. So therefore, G of R is a subset of negative infinity to negative 2. What's after the arrow on the second line? Here? This symbol means there exists. I should not use it because you guys haven't learned it yet. This symbol means there exists. It's a notation, okay? Are we allowed to use a equal sign, a line inequality? What do you mean? You mean here? Are you talking about this line? Oh, okay. Never mind. Anyway, since I'm marking your problem set, you are allowed to use this, okay? I don't care if you use it or not. I really don't care. Why is it? Because we have this equals to that, and we know this is greater than or equal to 0. Therefore, this is greater than or equal to 0 as well. Does that make sense? Okay, cool. So for the second part, I want to do some rough work first before we do the actual proof. I'm going to use green for rough work and blue for the actual proof. What does sit mean? Oh, that's not sit, that's such that. Okay. This is S dot T, which is a short notation for such that. Okay. Any other question? Can we use that for proving too? Yes, you can use that. If I used it, then you can use it. Since I'm grading, I really don't care, okay? Well, I'm grading your next quiz as well, so even on the quiz, you can use such that or there exists as well, because I'm grading it. I'm grading the second question. Daria's grading the first question. I'm pretty sure she doesn't care either, so Anyway, also by the time you write your second quiz, you guys should know those already. When you talk about logic, you'll learn those symbols. Can we move on to the second part? So I want to do some rough work, as I said. Now it's rough work, okay? So this is not the formal proof. So my rough work is, first of all, you want to realize what you need to do. So we want to pick an arbitrary element, which is y, pick it from the interval, and I want to show there exists an element x in your domain, which is R, such that g of x equals to y. So you can see that this sentence, I wrote it before as well. Here it is given, okay, because we let your y be an element of your image, so it's given already. Here we want to show y is, we want to prove y is an element of this. So that's what we want to prove now. So it's like the reverse. Now, so let's say if we have y equals to f of x. So right now I'm starting with what I need to prove. That's why it's rough work. Okay? Because again, I want to show we have x in real such that this is true. And now I'm starting with what I need to prove. So that's why it's rough work, it's not a formal proof. So suppose we have this, then we know that y equals to -2 minus the absolute value of 3x. Okay, this means that we have y plus 2 equals to negative the absolute value of 3x, or let me just, or we can just write this. Okay, basically you have this. Do you have this? Y plus 2 equals to blah blah blah. Yeah, so basically you have this. Now we want to remove the absolute value symbol, so that's gonna give you two cases. You either have negative y minus 2 equals to 3x for x is greater than or equal to 0, or you have negative y minus 2 equals to negative 3x where x is less than or equal to 0. Less than 0. Okay, so in other words, this can give you something like this. Because I want to isolate x. My goal is to isolate x. I want to see what my x is. So this is going to give you x equals to negative y minus 2 over 3, or x equals to negative y minus 2 over negative 3. Okay, does that make sense so far? Can I use this symbol for such that I don't suggest you to do that? You can use it in the stats notation. So if you have such like this, such that a plus 1, or such that a is less than or equal to 1. Okay, so in this case you can use this because this is clear. Sometimes we use this as well. But in a sentence, I don't suggest that. In a sentence, I don't suggest this or this. Okay, in a sentence, it's better that you use this. But in the set notation, it doesn't really matter. Okay, any other question? Okay, so here is my rough work, and I know that my x is either this or this, so I'm gonna pick one of them to be my x. So let me write in blue and make my rough work smaller. So I'm gonna pick one of them. So let's actually, I still need to write this. Pick y equals to that. So let's do that. Pick y be an element of negative. Oh my god. Okay, so that's my first step. And I want to find an x in real such that g of x equals to y. So I'm going to pick one of those. I'm going to pick this one. So I'm going to let x equals to negative y minus 2 over 3. And I know this is a real number since y is a real number. Okay? So that's my x. Right now, you picked your x and you showed your x is in real number. Now you want to show that your g of x equals to y. So g of x is going to be equal to negative 2 minus the absolute value of 3x, so 3 times negative y minus 2 over 3. So that's going to give you the absolute value of negative y minus 2. This is going to give you negative 2 minus negative y minus 2. Why is that? Rough work again. Why is that? Since we know here, since y is less than or equal to negative 2, okay, we have this, which means negative y minus 2 is going to be greater than or equal to 0. Does that make sense? Since we know what's in the bracket, no, what's inside the absolute value of what's inside the absolute value is going to be greater than or equal to 0. So when you take out the absolute value, it's just going to give you the same thing. So that's going to give you y. So here we have g of x equals to y, where your x is a real number. Okay? You need to write here. Oops. Since y is an element of negative infinity to negative 2. Alright, so you have g of x equals to y. Therefore, your y is an element of g over r. Any question? And since you showed that, therefore therefore the interval negative infinity to negative 2 is a subset of g over r. G of r. Wait. You don't need to. Why is that? You got okay. Let me answer questions separately. First of all, you asked, do I need to prove the other case? You don't need to, because the other case is sort of the same. Why is that? Okay, I'll tell you why is that. Let me use another color. So basically, you just need to find an x in real number. You just need to find x in real number such that it gives you this. We found such an x. This is just another x that can give you the same result, and I'll show you why it's the same result. So let's suppose we picked the second one. Okay, this is in R as well, since for the same reason, because your y is in R, then your g of x is going to be negative 2 minus 3 times negative 3 negative y minus 2. Okay, so those two cancels out. And what is this gonna give to? So now you have negative y minus 2, so you get y plus 2. So you get negative 2 minus y plus 2. And now you know your y. So let me write it here. Your y is less than or equal to negative 2, which means your y plus 2 is less than or equal to 0, which means this will give you negative 2 minus negative of that. So minus negative of y plus 2. Okay? So that's going to give you the same thing. That's going to give you y as well. So no matter which one you pick, so you can either pick this one or pick this one, you will get the same result. Does that make sense? Yes. Okay, Nicholas. Oh, you understand why it's y already? Basically, they cancel out. Okay, so negative 2 plus 2 and negative, and this will give you y. Okay, cool. So that's the end of the question. I basically showed you all different things. So one thing I want to emphasize is that if you write this, and eventually you're like, oh, your x equals to this, and x is a real number, that's rough work. Okay, that's rough work. You cannot do that. You have to give me an x that's in real number. So you give me x as like an expression of y, and you work on that. Eventually, if you can get g of x equals to y, then you are done. Will this be considered one of the easier quiz 2 questions? I don't think it's one of the easier question. It might be like a normal question or on the harder side, I would say. Because I think this was on one of the quiz last year, and people did not do well on this. The thing is, like, for 102 students, whenever they see absolute value, they freak out. So, I don't know. We'll see. I don't think it's hard. I don't think it's hard, but people think it's hard. So, it's really important that you understand this. No, I don't think it will be easy compared to the others. They don't give you really, really hard questions. Do we need to prove both sides for this to be correct? What do you mean both sides? We proved both sides. We proved this side and this side. But yes, you need the both, because yes, you need both because you wanna show the image of the function equals to this. So my conclusion is therefore g over equals to negative infinity to negative 2. Okay? Any other question?
Hi.
Hello.
Okay, good. I was just wondering, it's a bit easier to just say it out loud. But would you suggest that if we're proving something is equal, we always do subset or double subset?
Okay, this is what 102 want you to do. That's what I would say.
Okay.
It might not be the easiest way, but this is what 102 want you to do.
Okay. Thank you very much.
Okay, no problem. But isn't image not always equal to the codomain? You're right, image is always a subset of the codomain, but they are not necessarily be equal. Well, in this case, they are not equal because the codomain is R and your image is this, so they are not equal. So I'll write it down since it's pretty important, okay? So your image is always a subset of your codomain. but they are not necessarily equal. G over R is an image, yes. Any other question? Okay, I suppose no question. Then let's move on. Activity 2. They want you to prove that if f from A to B for any set C, D are subsets of A, then you have this. Again, I'll give you some time to think about it and we'll take it up. We only have 10 minutes left. So, just like last week, after 10 minutes, you can leave. You don't have to stay, but I will stay and I will finish all the questions. Okay? I'll give you 3 minutes. So at 5:54, we'll take it up. Oh, I'm hungry. What did you guys eat for lunch or dinner? Did you guys eat dinner yet? No. So I suppose everyone's gonna eat dinner after this. I don't know what to eat anymore. I wanna get bubble tea, but I don't know which one to get. You're having pad. I love pad thai. You got cup noodle. You should eat more. Like have more nutrition. I love pad thai. I always want them to add like extra spicy to it. But one day I remember I got pad thai, and in the middle of that I was getting something, so I moved from my chair and my dog stole my pad thai, and he ate half of my pad thai. And remember I said I like it to be extra spicy. So when I ordered it, I said extra spicy, and when I got it, I added like extra chili sauce on it. So it's really spicy, and my dog ate that. For the next 2 days, he was having diarrhea. It was really bad. And I was like, I guess my dog's ass is on fire or anything. Yeah, it was really bad because, like, I can't even take him out because he was having diarrhea. It's gonna be extra awkward if he, poop outside because it's really hard to clean. Yeah, so after that, I thought he's not gonna steal our food anymore because, it's not a good experience, but he still keeps stealing food from us. I just need to be extra careful about my dog. Alright, it's about time. Let's do this question. So, again, you're trying to prove one set is a subset of another set. So you pick an arbitrary element from the set. Let y be an element of FC intercept, no, not intercept, minus f of c intercept f of d. Okay, so that's my y. From this, we can get y is also an element of f of c, and y is not an element of f of c intercept f of d. Okay, so based on this, my question is, what's my next step? Well, we know this is true, and what? Anyone know? What's next? And y is not an element of f of c. No, so now is it and or? That's my question. Think carefully. Remember last week? Last week we did something like this. Remember I told you guys this is x is in A and x is in B, and this will give you x is not in A or x is not in B. Okay, so it's or. Y is not in f of d. Please, please, please remember this. This is a really, really common mistake, okay? People make the mistake all the time. All the time. No matter how many times I emphasize it, they still make the mistake during the quiz. So I hope you are not the ones who make the same mistake. This will give you y as an element of f of c, and y is not an element of f of c, or y is in f of c and y is not in f of d. So from this, what do we get? It can be both as well though. No, 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 no. So think about this. This is your A, this is your B, this is A intercept B. I'm telling you x is not in A intercept B, so x is not in there. So that means x is either not in A or not in B. So it can be in A, then it cannot be in B. Or it can be in B or cannot be in A. So it cannot be in both at the same time. So this means x is not in A or it's not in B. What if it's not in either A or B? Well, it can be here as well. Yeah. But this covers that too. It's not in A, it doesn't mean it has to be in B, right? We're just saying that it's not gonna be in A or it's not gonna be in B. Anyway, what does this imply? The next line. What's the next line? What's the next line? first one is impossible, exactly. So this will give you y is in f of c, and y is not in f of d. Okay? Now, if you look at what you need to prove, you need to show this. We are not getting there. Why is that? Because here you're only talking about y, but here you need to change the domain as well. So that means we need to talk about x. So since y is an element of f of c, which means there exists x in c such that f of x equals to y. Okay? And we know y is not in f of d, implies that there does not exist x in d such that f of x equals to y. From here, we know that we don't have an element that's in both c and d. So this means there does not exist an element in c intersect d such that f of x equals to y. So we don't have that. Okay, so we don't have an element in both c and d because we know that we don't have such element in d to make this work, because we know this is true. Okay, so we don't have that. That means so that means since we have x is in c and x is not in c intersect d, that means our x is in c minus c intersect d. Okay, and we know that f of x equals to y, so that means y is in f of c minus c intersect d. And this means f of c minus f of c intersect f of d is a subset of f of c minus c intersect d. Okay, any other question? Question. Nope. Now, the second part is, are they equal? So we proved this direction. So when they ask are they equal means, is this direction true? Is this a subset of this? Yeah, I'm lazy too. So we don't need it's better that you write this, but if you don't write it, it's fine. I don't care. Okay, I'm lazy too. So if you end here, that's okay for me. It's better that you have this, but if you don't have it, that's fine. That's perfect as well. Okay, how could I find out? Try different values. Okay, I'll tell you it's not true. It's false. 2. No. And I'll tell you a trick for test and quiz taking. Usually when they ask you, usually if they are equal, they ask you to prove they are equal directly. Okay, usually. It's like 90%. And if they separate them, that means usually the second part is not true. And you need a counterexample. Does that make sense? Usually, okay? I'm not saying 100%. But yeah, because I don't want you to spend a lot of time trying to prove it and realize it's not even true. So it's not true. So we just do the second part by making arbitrary C and D and not prove the first. I don't understand. So the second part, you just need to find counterexamples. You don't need to prove anything. Yeah, you just need to find counterexamples. Okay, so for counterexamples, here's another trick. For counterexamples, and you have a functions, usually, okay, again, usually two functions are really helpful. The first one is x squared. The second one is the absolute value of x. Okay, so for me, when I have a look at this question, I don't even know if it's true or false, and I don't even know any of the functions gonna work, but I'm gonna try x squared, and let's see if it works. So let's say our C, since I want to use x squared, so I want to use like positive numbers and negative numbers, and D equals to 0, 1. Okay, so you can see they can have the same image. And my f of x equals to x squared. Okay, in this case, your f of c equals to 0, 1, which equals to f of d, which equals to f of c intersect f of d. Okay, so which means the first part, this will give you f of c minus f of c intersect d intersect f of d. Both are 0, 1, so that's going to give you the empty set. Now c minus c intersect d. So c intersect d will give you 0. C minus 0, that's going to give you negative 1. And f of c minus c intersect d will be f of negative 1, which will be 1. And we know that 1 does not equal to an empty set. Down. Okay? So this is another trick. You need to think of counterexamples. So first of all, you need to try to make it as simple as possible. So don't make your C be all the integers or like all the rational numbers. Don't do that. That's gonna make your life really hard. So use like examples that can be as simple as possible. That's the first thing. The second thing, the functions such as x squared and absolute value of x, they're like really, I would say, really special functions that can make a lot of counterexample work. So those are my tricks. Any question? Oh, another thing is you don't do that. When you think something is false, don't try to prove it. The reason is you can't prove it's true. It doesn't mean it's true. It might just mean that your proof is wrong, or you just can't prove it yourself. Okay, you can't prove it doesn't mean it's false. But if you have a counterexample, then that shows it's false. Does that make sense? Like, think about it. There are a lot of open questions. We know they are true, but no one can prove it. So you can't prove it. That doesn't mean it's false. But could it be true in another number field? In another number field? I don't think so. Because for number fields, they all have the same operation. Yeah, for number field, they are all subfields of R. So it's still false unless you're talking about Even if you're talking about field with characteristic P, it's still be false. Yes, you just pick something and make and as long as you can show it's false, then you're done. Anyway, can I move on? Here we're not doing field yet. Here is just a set question. It's not even field. It's not enough. It's not. We're not talking about field, but your question, it's not true. Anything false in one field might be true in another field. But here we're not talking about field, okay? Now it's just sets. And they're just arbitrary sets. They can be in any field, if you wanna say field, yeah. So right now let me just write a equals to b equals to r, or rational numbers or something. Anyway, can we move on? Okay. Activity 3. Again, you're free to leave. You don't have to stay since I passed time already. Activity 3. Which uh which of the following is a field under normal addition and multiplication? So let's look at the first one. R intersect Z. What does this give us? Yes, I will post the recording later. You don't have to stay. That's what I said. You don't have to stay. I will post it later. You don't have to stay. So this will give you integers. Is integer a field? And why is it not a field? Integers is it a field? No. Okay, it's not a field because we don't have reciprocals exactly. No reciprocal. Second one, let's say 0 to -2. Is this a field or not? No. Why? Also, this is wrong, right? Let's change it. 0 to 2 instead. You either say 0 to 2 or -2 to 0. You don't say 0 to -2. Okay, no. Because no negative. Or no additive inverse. Okay, so for example, you have 1, but you don't have -1 to make it 0. Alright, number 3. And number 3, n is an integer. Is this a field or not? Is this a field? No reciprocal, still no, exactly. So for example, reciprocal. For example, you have 5/3. You don't have 3/5. Okay. 4. Number 4, is this a field? What's reciprocal? Reciprocal means another element in the field such that if you multiply this with the original element, you get 1. That's reciprocal. So in another word is multiplicative inverse. Alright, this one, is this a field or not? Yes, no. It's not a field. Why is that? Anyone know? No negative. A really obvious one is you can't have 0. No 0. So no, what's 0 called? Additive identity? Yeah, additive identity. Because you need to make sure you have 0 and 1 first, which is 0. The last one is this. What is this? What is Q union Z? Q. Okay, so is this a field? Is Q a field? Yes, you proved it in class. Hopefully you proved it in class. Can't make any assumption. Number 2, you have a field with 3 elements and they want you to find this. Okay, anyone know how we can do that? So basically, since they don't need you to prove anything, I'm gonna use the addition table and the multiplication table for this one. But notice that you can't use it when they ask you to prove anything, okay? You can only use it if it's filling in the blank. Unless they have it in the textbook, which I don't know if they do. If they do, then you can use it. I don't think they do. They do? Okay, then that's shocking. Then you can use it. 0, 1, x. 1x. 1 plus 1 is x. 1 plus x is 0. And x plus x is 1. 0, 0, 0, 0, 0. 1 times 1 is 1. 1 times x is x. And x times x is 1. Okay, since nobody know for sure, let me write it down. You can only use them if it's fill in the blank. Okay, for those two. If it's not, you have to prove them, okay? But here, you don't need to prove anything, so let's just use them. Now, x cubed plus x times x plus 1 squared plus 1. X cubed is x times x times x. Okay, so let's check. X times x equals to 1. So that's going to be 1 times x. 1 times x. 1 times x. So 1 times x will give you x. So x cubed equals to x. Plus x times x plus 1. X plus 1 give you 0. So that's 0 squared plus 1. Now 0 squared, which means 0 times 0, which will give you 0. So that's going to be x plus x times 0 plus 1. Now x times 0 will give you 0 as well. Now let's check x plus 0. X plus 0 will give you x, and then x plus 1, x plus 1 will give you 0. So the final answer is 0. 0, 0, also 0. Okay? You don't get how I got the values in the table. I proved all of them. That's how I got them. Okay. The ones you don't need to prove are, we know that 0 plus any number will give you that number back. So this, you don't need to prove them. Okay? You know those already by the additive identity. Now, you know 0 times any number will give you back 0, so you don't need to prove that either. Also, you know 1 times any number will give you back that number, so you don't need to prove those either. So what I highlighted, you don't need to prove them. What I did not highlight it, you need to prove them before you use them, okay? Now, if you don't know how to prove them, give me a second. If you don't know how to prove them, I'll show you. Actually, let me just show you here. If you don't know how to prove them, go to Quarkus, go to module. Can you guys see this or no? Go to Quarkus, go to module, and then go down, go down, go down, go down, go down, go down, go down. Tutorial materials, and here, tutorial 010, 9101, 9106 with Lean. Click this, you'll see week 3 material, okay? And here I have videos. I have failed part 1, failed part 2, and failed part 3. If you click them, that links you to the videos I explain those. Okay? Oops. Uh-oh. It's gone. Let me reconnect. Okay, it's back. It's back. So, again, if you don't know how to prove them, check those 3 videos. If you have problems with image proofs, check this video. Okay? If you want set identity proofs that involves function, check this video. Also, I have other resources here, which gives you the tutorial worksheets I made last winter, so you can check those as well. And the recording will be posted here. Additional tutorial videos, I'll post them later here as well. Okay? Now, is there anything that does not make sense? Any question? Any question? If not, let's see end of the tutorial. You didn't know? Okay, I've been posting those for 3 weeks. All the informations you can find them here. Okay, all the informations about my tutorial you can find them on my Quarkus page. All right. Any question? Guess what? This is another. Well, you're not too late. Now you know. Okay, what's your off-topic question? You don't get what if and only if means in the quiz. That's not off-topic. Let's talk about it. It's really, really important. If and only if I don't know if you were in my tutorial for the last 2 weeks, but if and only if. Remember, I always use this double-headed arrow. This means if and only if. It means that, so for example, we have P if and only if Q. This means P implies Q and Q implies P. Okay? P implies Q and Q implies P. So this means that you need to prove, if they ask you something like this, then you need to prove if P then Q, and you need to prove if Q then P. Did I answer your question? Okay, cool. All right, so problem set. Let's go back to my Quarkus page, okay? My Quarkus page here is a to-do list. You guys see the to-do list? This week, you're supposed to work on problem set C, because this one is the one you need to hand in. It's due this Saturday. Problem set D is posted as well, but that's for you to prepare for your next quiz. So tonight I will update this page. I'll give you information about week 4. You don't see D? D is here. Problem set D. Click that and you'll see. Okay, so you don't need to submit this. You don't need to submit D, but you need to submit C. So you need to do C first. And D is for practice for quiz 2. Okay?
Hi, can you hear me?
Yes, I can hear you.
Yeah, I was looking at the questions from problem set D, and I don't know what does a question mean,
D?
like D, yeah. So
D?
one question, yeah,
Which
D.
one?
So the question was like, is F bounded or not? What does bounded mean? Are we
Wait,
supposed
which
to
question are you talking about?
um 2.5.30 from the problem set D, right?
2.5 point what?
30.
30?
Yeah.
13. Oh, 13.
Okay, 30, 30.
13,
Wait,
which part?
did I see it wrong? Yeah, 2.5.30 from problem set C. Sorry, problem set C.
C. Okay. From C. And it's 30, right? Oh, bounded. You're asking about bounded?
Yeah, I don't understand that one.
Uh, the definition is in 2.5.29.
So are we supposed to have that in lecture already or not?
I don't think they ever cover it in lecture.
Oh, okay. Okay, okay.
Yeah, so you need to read 2.5.29 to understand the definition, but it's under problem set, which means they still can test you on this. Okay, so make sure you know how to do them.
Okay. Thank you.
Any other question? Me too. I'm hungry too. Okay, I'm really hungry, guys. If no question, let's all go eat. Why do I even do lecture if we normal? You need to go to lecture for participation marks. Okay, guys, let's all leave here. Go eat your dinner because I'm hungry. And thank you, everyone, for staying. And I'll send you a survey later to get feedbacks. So please, everyone, fill in the forms, the feedback forms. Okay, I'll send you later after I finish my dinner. Anyway, bye.